So question 20. A company publishes data on its quarterly earnings for its stockholders to evaluate. Is this data primary or secondary source data? So I will think about it and I will put up the polling. You have your 4 choices. And so if you can vote for that, we'll see what the appropriate response is. Does everybody see the voting? Yep, okay. Okay, John, can you please vote? Okay. Thank you. All right. So, Tony, can you explain why you said it was the first option? You can use your microphone or you can use chat. Tony, do you hear me? Because the company collects the data by themselves, so it's primary for them and secondary for the stockholders, okay? And Roshani and Wellington, you said it was number 2. Source is primary for both the company and the stockholders. So can you explain that answer?
In my opinion, like it's a primary,
Not
the
an
same
opinion.
as
You got to give me the fact.
yeah,
Remember,
like
what is a primary? What is a primary?
when you gather the information is a primary source. So for the both of them is primary because the company just publish, so the stockholder just analyze.
And who collected the data?
The company,
And who did the analysis?
the stockholders, but they are
The
only seeing the
stockholders did the
analysis.
analysis of the
No,
data?
no, no. So yeah, I
No.
know. Okay.
Okay. Okay, I'm going to go back to what we talked about on Tuesday. Read the question carefully. Read, if you're going to have multiple choice, read the multiple choice. The stockholders did not have anything to do with the collection or the evaluation with the data, right?
Yeah.
Okay. And you understand that, Roshani? Okay. And John, you said number 4. Was that a guess? John? Okay. All right. This is important. You have to understand the difference between primary and secondary sources. Okay. So let me show you. Okay. So why did you pick number 4? If it's secondary for both the company and the stockholders, explain that. You had to be quick. No, that's not answering the question, John. What's the difference between primary and secondary sources? Do you know what the difference is? Are you not sure what it is? No, it's not. You're not discovering the source. You are creating the data. That's the primary source. You are creating the data. Okay? So the company created the data. They are the primary source. And the secondary is when you get it from another source. Right. Okay, is that clear for everybody? Any questions about that? All right, we'll go to the next one. Yeah, it is A. All right, so question 21. If you have a digital scale in your home that only reads in integers, is your weight a discrete variable? And what I'm going to do is do the polling again. Okay, so if you can please select. Well, just imagine what it might be, John. Okay, people vote. Tony, Brissa, can you please vote? Okay, then keep it no response then. Samar, can you please vote on this question? Are you hearing me, Samar? I guess not. Oh, okay, you're reading it. All right. So we have two people, Roshani and Samar, that said it's number 1. No, because weight is still a continuous variable regardless of the ability to measure it. All right. So Roshani or Samar, can you explain why you said number 1? Oh, you chose number 2? Oh, sorry. I'm sorry. Okay, John and Wellington, you chose number 1. So can either of you explain why you chose number 1?
Because like it doesn't matter like your measure, like
That is correct. It
if a
doesn't
variable
matter
is
how you're
continuous,
measuring it, right?
yeah, exactly. It's
And what
keep
else?
continuous. It's a continuous variable, so because of this.
Right. Okay. Everybody understand that. It doesn't matter what the scale or whatever measurement device you have, weight is still continuous. All right. Okay. So it's a continuous variable, John. We're not talking about ratio variables. All right. So let me show you. If we go to the answer, weight is intrinsically continuous and does not depend on the accuracy of the scale. All right. That's why you have to, I can't emphasize more, read the question carefully. That's the most important aspect because then you're going to understand. A continuous variable, okay, a continuous variable has no finite end. Theoretically, somebody could weigh 9 million pounds. They're not going to weigh 9 million kilos. They're not going to weigh that much, but theoretically, somebody can weigh that much. There's no negatives, right? You can't weigh negative kilos or grams. Is that clear, Roshani? Yep. Okay. Let's go to the next question. Number 22. Okay. A question on a product registration card asks, how much money do you plan to spend on DVD movie purchases during the next 6 months? Sorry, it's old. What type of variable and level of measurement does your response represent? Discrete variable measured on a nominal scale, a continuous variable measured on a ratio scale, a discrete variable measured on an ordinal scale, or a continuous variable measured on an interval scale. And I will just put up the polling. Sorry. Oh my God. Okay. Okay, so if you can make your choice. Remember, if you don't want to make a choice or you don't know, just leave it at no response. All right? Okay, so are 4 of you saying you have no response? Oh, Amir, okay. Roshani and Samar, you don't know? Okay. Samar, you're not sure of the answer? Just indicate yes or no. Okay. All right, so Amir, tell us why you selected number 1. Amir, can you hear me? It's nominal, so it's a label. Uh-huh. It says, how much money do you plan to spend on DVD movie purchases during the next 6 months? Why is that nominal? Why is money nominal? Ah, okay. So now you're saying it's number 2. A continuous variable measured on a ratio scale. All right, so 3 of you said that. Okay, Tony, can you explain why you think it's number 2? You can use your microphone or you can just type something in the chat. So we established money is a continuous variable. Ah, are you sure? You have to be sure. It just says, how much money do you plan to spend on DVD movie purchases? You're going to write in a number, correct? Right. Okay. So we established that it's a continuous variable. Nobody said number 4. And a meaningful 0. And what does that mean? What does a 0 mean with regards to this question, Amir? Exactly. It has meaning. The zero is meaningful. All right. So, currency is continuous and a zero expenditure represents no purchases, but it does represent something. All right. Any questions about that? Okay. Okay. All right. So the next question. The number of students on a college campus is a continuous variable. True or false? And just let me get the little polling thing here. Okay, so yes is true and false is no. Okay, so 5 of you said yes and 1 of you said no. So Amir, why did you say no? Or sorry, false?
Can you hear me okay?
Yep.
So for continuous variable, it's like you're counting forever and you cannot finish counting. So like on that
Okay.
on that note, I think it is false, this statement.
You mean it's okay. All right. And anybody who said yes, why did you say it was true? Chat or use your microphone. Okay. Are the number of students on a college campus a continuous variable? No, it's not a continuous variable. It's a discrete variable. Okay, because there's only so many people on a campus at a time, and that number certainly can vary at different days or times or whatever you want to measure. So the people that voted yes, do you understand that? It's not continuous. It cannot go to positive, theoretically go to positive infinity, right? Because there's a finite number of students or instructors or people who work there. That's a finite number at any given time. Does everybody understand that? Okay. Even though it is a relatively large number, the number of students on campus is discrete. Okay. It can be defined. It's discrete, so you can just count them. Is that clear? Does anybody have a question about that? No? All right. We'll go on to the next question. All right. Companies are classified by the sectors in which they operate, such as communication, agricultural, and manufacturing. The sector is a categorical variable measured on an ordinal scale. True or false? Oh, sorry. Okay, can you vote on that one, please? And remember, read the question carefully. So yes is true and no is false. And remember, if you're not sure, don't vote. All right, so 4 of you voted yes. Roshani, why did you say it's true? What's the scale that they're saying this variable will use? Ordinal. And what does ordinal mean? A ranking. So are you ranking these categories? Are you ranking communication, agricultural, and manufacturing? You're saying one is better than the other one? No, exactly. This is, it's, these are categorical, but you're not ranking them. You're not saying, oh, communication is 1 and agricultural is 2 and manufacturing is 3. You're just categorizing them. So they cannot be ordinal. Ordinal has to do with ranking. All right, everybody, any questions about that? Okay. So one market sector is not better than another. Therefore, it cannot be an ordinal scale. So if you're going to remember something, if you think of ordinal, think of order. Okay, this one comes first in the order. This one comes last in the order. Remember, there was another question on Tuesday about, strongly agree to strongly disagree. That's ordinal. You're ranking them. You're saying one is better than the other one. All right. Qualitative variables, which is like, the color of your hair, the color of your eyes, are restricted to exactly 2 responses, such as yes or no and male or female. Is this true or false? And let me just, so if you can vote on that one. All right. So Samar, Tony, you have no vote. I just want to be clear. Oh, okay. Oh, a split vote. All right. Okay, John, why is this true? Why qualitative variables are restricted to exactly 2 responses? Why is that true? John, you don't know. Okay, that's why I said make it a no response. Okay. Um, Roshani, why did you say it was true? What's a qualitative variable? What's an example of a qualitative variable, Roshani? I mentioned it previously. Eye color. Okay. So Roshani, are there only 2 eye colors? No, which means the correct answer is it's false, right? Okay. Categorical variables can have, depending on what you're looking at, they can have multiple responses. All right. So again, I'm going to go back. Read the question carefully. Any questions about that one? All right. All right, the next question. Grade point averages are an example of interval levels of measurement. Oh, sorry, I forgot to put the polling in. My error. Okay, so grade point averages are an example of interval levels of measurement. Yes is true, false is no. So if you can vote on that. And if you're not sure, don't respond. So Roshani and Samar, you're not sure? Okay, Samar is done. Roshani, what does that mean? Yeah, you're not responding, you're not sure. Okay. All right. So 4 people said yes, 1 person said no. Okay, Amir, why did you say this was false? Amir?
I would say like it can't be negative, and like
Okay.
we use ratio because of the meaningful zero. So on that note, I think it is false.
Okay. And Tony, can you explain why you said yes, it's true? You can use the chat or you can use your microphone, Tony. Why did you say it was true? I think it's from 4.0 to 0. Yeah, that's correct. But why does that make it an example of interval levels? Oh, so it's an interval. Okay. So I'm going to remind everybody, when you have interval data, what you're talking about is the magnitude of the answer. So if somebody says 5, or somebody responds with a 5 and somebody responds with a 1, that means the 5 is 5 times the answer of the 1. Is that true for your GPA? If somebody gets a 4 on their GPA and somebody else gets a 1, is the 4 times more than the 1? Yes. Okay. Remember, their GPA is an aggregate of all their courses, so maybe that was not a good example. But let me show you. Okay. So in order for a GPA to be a ratio, an A average 4 would need to be twice as good as a C average 2. Is that correct? Which is not a true property of grades. Okay, it's a little fuzzy, but in order for it to be a ratio, your number must be like that much times less or that much times greater than. So if somebody got a B, which is a 3, and somebody got a C, this is their grade point average based on all their grades, is a 3, sorry, is, I don't want to say 3, is a 3 in your average 1.5 times more than your C? It is mathematically, but is it within the grades? Because you could end up with an A, you could end up with a D, and you could end up with a B and a C, and you end up with a C average. So those grades accumulate to a GPA of 2, and somebody gets a GPA of 3. Is that 3 1.5 times more than that C? Numerically, yes. But remember what's making up the final number, which is the GPA. Do you understand the difference there? I know it's very subtle. Yes? Any questions about that? It's very close. Okay. Oh, so is it true or false? It is false because it is not a ratio, which means the order of the magnitude is numerical. Okay. All right. Yeah, you were correct, Amir. Okay, number 27. How might you obtain a statistic that is a numerical value from a categorical variable that has a yes or no as the only possible responses? All right, let me do the polling. Okay, does the other three people not know? Amir and Samar? Sorry, I'm the third person. Sorry, Amir and Samar. Are you not sure about the answer? Oh, you're still thinking. You're not sure, Samar? Okay, so just keep it at a no response. So you got to think about it carefully. How might you obtain a statistic that is a numerical value from a categorical variable that has yes or no as the only possible responses? Okay? Okay. Congratulations, everybody. You are all correct. Okay, so obviously, no, you can convert a categorical variable to a numeric variable. Obviously, you understand that part. Okay. So, number 28, for a marketing class project, you ask your friends how likely they are to visit a particular restaurant. Your survey provides biased data. True or false? Let me put up the polling. Okay, Amir, Brenda, Samar. All right, Amir and Brenda. So Brenda, if you are not sure about the answer, just don't answer. Just keep it at no response. Okay. All right. So I'm going to ask Samar. You said that's false. So in this situation, why does the survey not provide, why is it unbiased data? Can you explain that? You're not sure, then you should have kept it at no response. Okay? Because everybody else is correct. Exactly, Samar. That is why it's biased. You're only asking your friends. So you're going to get a biased answer. It doesn't matter, John. You're asking your friends. It's already biased. Okay? The important thing is when you are doing, what is the most important thing? To keep it random. And your friends are not random, they're your friends. All right? So everybody understand that concept. Okay. Number 29. A parameter is a numerical measure of a sample characteristic. True or false? Okay, remember, if you're not sure, keep it to no response. Okay, so 3 people have yes and 1 person said no. All right. Tony, sorry, Roshani, can you explain why you chose yes? A parameter is a numerical measure of a sample's characteristic. You said that's true. Why is it true? Oh, Samari, okay. So Roshani, any reason why you said yes? Did you choose it just because it was there? I don't want people guessing. I want you to understand exactly what it's asking. Are you there, Roshani? Why did you say yes? Why did you say yes, Roshani? What is a parameter? Okay, Roshani?
The population.
The population. So is that a numerical measure of the sample characteristic?
Mm,
Is the sample and the parameter the same?
oh, no, it's different.
It's different. So the parameter cannot be a numerical measure of the sample characteristic. So I mean, it's the language, but parameter refers to population, you know that, and sample refers to the sample, which is a portion of the population. So it cannot be a measure of the sample. Okay, do you understand that?
Maybe I didn't understand the
Yeah, you've got to
question.
look at the question carefully. Okay,
Yeah, okay.
so a parameter is a measure of the population. It is not a measure of the sample characteristic. So parameters refer to population characteristics, while statistics describe sample characteristics. Okay. All right. So this, I just want, if people can, you know, put up their hand or they want to say something, describe how different business areas, accounting, finance, management, and marketing might use statistics. So if anybody wants to say something, please. If somebody wants to talk, they want to raise their hand, that's fine too. Okay, and can you elaborate on that, Rashani? Why would they want to make decisions?
For example, finance probably no. We will use statistic to see like stock marketing. So marketing we will use statistical for understand a specific field or clients that they want to get the attention.
Okay. Anybody else?
I
So
think
John's,
yeah, so I think in management, maybe they can use statistics to know the cost of the product.
so what is, okay, so
Uh,
Roshani, what does management do?
uh, it's a, they're, I forget.
Well, they're running whatever the company is, right?
Uh,
So they have
yeah,
to be concerned about the employees. So they have to be concerned about salaries. They have to be concerned about what are the responsibilities of the employees are. Okay. So they might look at, and I don't know if any of you have worked full time in any kind of uh, position, but part of management duties are to look after, is there any, oh, I don't know if anybody in the class today is an HR, but that's a very important duty that HR worries about. If person A is not doing their job, they're looking at the data, you know, whatever the evaluation is, they're looking at it and they're saying, no, you know what, this person is not producing. We better come in. They better come in and we got to talk to them. Okay, so you understand that one, Rashani? Okay, so let me show you. So this is a possible answer. Accounting might use statistics to select what items to audit that might have values that differ the most from the others. So accounting might say, well, we don't want to produce this anymore, or we want to produce more of this because maybe the statistics it's showing is there's more popular demand for it. Finance might use statistics to track trends and costs. So they want to see things are going up or things are going down or things are staying the same. And management, as we talked about, might use statistics to determine the quality of a service so they could improve the certain aspects of it. And marketing might use statistics to determine which pilot project to pursue. You know, how much money are we going to put into a particular project, right? Okay. This question, discuss the relative weakness of categorical variables, including measures on nominal and ordinal scales, and continuous variables, including measures on interval and ratio scales, with respect to the type of information that can be obtained from the statistics. So if anybody wants to speak up. So what can you tell me about the weakness of categorical variables? So I'm going to give you an example. We want to know all the eye color of all the employees in the company. Okay, so now you have the eye color of everybody who works in the company. Is that a weak variable or a strong variable? Yeah, it's time consuming, Brenda, but what else is it? Is it a weak or is it strong? Okay, why is it strong, Song? Why is it strong? Tell me why knowing the eye color of every employee in the company important. What can you do with that data? Anybody?
I
Okay,
think it's
why?
weak.
Yeah,
I think it's weak because like normally you don't have anything like you have the number of people that have like brown eyes or blue eyes,
yeah,
but like what is its relevance to understand the company, you know? So like,
yeah, but why? What if we put all the people with blue eyes in finance and all the people with brown eyes in marketing?
but
Can we
this
do
is
that?
not a competence, you know? Like,
Ah, okay, okay. And that is why categorical data can only tell us a certain amount of things, right?
yeah,
We know like how many people, yeah. you know, just using eye color. We know how many people have brown eyes and how many people have blue eyes. Okay, that's not, as Amir says, it's not really relevant to your business. It's an interesting observation, but it doesn't really help your business. And so why are measures on the interval and ratio scale considered strong variables? You only have to know really one thing of why you use those scales for statistics. Anyone?
I would say because you're dealing with numbers, and like a ratio scales almost cover all the numbers that you need, negative, zero, or positive. And so like you get the better understanding of your business, and you can make a prediction, or you can plan for the coming events.
Okay. But in other words, what you're doing is you're taking the measures on interval and ratio scales to make decisions, right? Because those decisions involve money. That's the most important thing in a business. So if we look at this summation, statistics on categorical variables that can be expressed on a nominal scale may only determine which values meet a certain criteria. And those that can be expressed on an ordinal scale may at least show a ranking structure. This information is weaker than the information gained from numerical variables, which show by how much values differ, particularly those variables that can be expressed on an interval scale. So the reason you're going to use statistics in business, and you know, I'm not from the business world, I don't work in business. I can't say whether it's used a lot, it's used a little, but it doesn't seem to be used enough. Okay, and that's why to me, it's very important that you are able to do statistical evaluation of the data, because there's so much data that businesses collect, they could make more sound business decisions. Anyway, so that ends chapter 1. Is there any questions about the content of chapter 1? No questions. Okay. All right. So now we are going to go to chapter 2. Yes, Amir, now you're happy. Now we're going to be in chapter 2. And I don't know why it's not doing that. Okay. All right. Whoops. That's chapter 1. I don't want chapter 1. Sorry, everybody. Okay. Chapter 2. What is the purpose of a summary table? A, to see differences between or among categories, to sum the values of responses to a survey. This is the only way to present categorical data in numerical form. Or D, to list data to create a bar or pie chart. So let me get the polling. Oh, for God's sakes. Oh, sorry. Okay, so if you want to respond to that. Okay, John, that's good. You don't know. All right. So you're still thinking. Okay. So Wellington, why did you select number 1?
Because I think on a purpose of a summary table is to see like the difference between everything, you know. So you have a summary, like you have all the statistic, and with the summary you can see like what is the difference. For example, there is a lot of one thing rather than the other, you know.
Okay, so basically you're saying you can see the totals,
Yeah. Oh, yes.
right? Okay, Amir, you said number 1.
Yeah, if I just add to what Wellington said, so
Yeah.
so summary table, so it's just we don't provide summary table just for creating bar or pie chart. It's not just for creating charts. So it's gonna tell us the overall how much value our categories has. So like it is
All
not
right.
just have to be for bar or charts.
Okay. Roshani, you said number 2, to sum the values of responses to a survey. So why did you say number 2? Remember, this is what is the purpose of a summary table? Roshani, are you there? Okay, we'll go back. We'll come back to her. You chose the wrong option. Okay, Roshani, you got to read it carefully. And Tony, you chose number 4, D. Why did you choose that one? You think you're wrong. Okay. All right. So let's see what the correct answer is. Well, that's one aspect to visualize the data. But the real purpose is you can sum the values associated with each category. The primary purpose is to allow the analyst to see differences between or among categories, because that is where you can say, oh, I can say, oh, there's a difference between this column that has 100 and this column that has 10. Why is there a difference? Then you can start analyzing it. Okay, so the summary table is either going to, well, it can do two things. So if you have, column 1 has 50 and column 2 has 50, you still are going to look at it. So why are they the same? Why are they different? The summary table is important because that's where you start to evaluate the data. Okay? Everybody's talked about there's different aspects of the summary table, but really the whole point of the summary table is, can I go on to the next level and evaluate the data, or I'm just going to leave it because this is sort of what I expected. Okay? All right. So, sorry, this is a little off. So consider the relative frequency distribution given below. You have the class interval, 20 but less than 40, 40 but less than 60, 60 but less than 80, 80 but less than 100, and the relative frequency is 0 0.3, 0 0.2, 0 0.1, 0 0.4. So if there were 50 numbers in the data set, then 30 of the values must be less than 80. Is that true or false? Okay, so if you want to do your vote. It's just clapping for everybody who's answering. Only one person has answered so far. Okay, John, then don't give a response if you're not sure. If you're not sure, don't put in a response. So are people not sure? Okay, keep thinking. Everybody still thinking? John, Roshani, if you don't know. Okay, you don't know? All right. And everybody's correct. Yes, that's true. Okay. %60 of the values are less than 80. Okay. Oh, so just before I forget, as we go along the chapters, you might want to have the tables with you and a calculator with you. Okay? You may in some questions, yes. All right. A graphical representation of a frequency distribution is called a histogram, time series plot, stem and leaf plot, or a scatter diagram. Okay. Okay, Amir, just do your own answer. Tony, are you not sure of the answer? If you're not sure, just tell me. Or if you're thinking, you're still thinking? Okay. Okay, I'll give you, all right. Okay. And everybody said it was a histogram. And everybody is correct. Good job. All right. You have a summary table and a simple bar chart indicating where customers prefer to do their banking. How could you enhance the bar chart to provide both visual and actual information? Only the summary table can show the actuals for the data. Add values to the bar chart like what is commonly done on a pie chart. The bar chart and summary table must be presented together in order to represent this data. Use vertical lines on the bar chart to show the values more precisely. Okay. Whoops. Okay, so if you want to put in your responses. Hey, John, do you know or you're not sure? Okay, that's fine. So 4 of you said it was number 3. The bar chart and summary table must be presented together in order to represent this data. All right. Noah, why do you have to do that? Why must the bar chart and summary table must be presented together in order to represent the data? You can use your microphone or you can use chat. Noah, can you hear me? Are you going to answer, Noah? Okay, well, if the data isn't clear and you can clutter up the bar chart or keep it readable, it would make sense to put them together. Okay. Anybody else who answered number 3? What's the reason for choosing number 3? Tony, why did you choose number 3? You think the summary table provides, visual information. Okay, and the bar chart gives the actual information. All right. And Amir, why did you choose number 4? You can still figure out the data based on the chart only. 2. Use vertical, okay. Use vertical lines on the bar chart to show the values more precisely. Okay. I will tell you that no one is correct. Okay. The number 3 is not true. You do not have to present the bar chart and the summary table. Okay. So, okay. So Amir, you said you thought it was number 2. Let's just see. Oh, sorry. There's no definition. But number 2 is correct. When you have a bar chart, I don't know if anybody or if everybody is the people that are here today, is everybody familiar with using charts in Excel? Is anybody not familiar with using charts? And I did put up, there's a folder on the website that has using Excel. So everybody knows how to create charts. All right. When you create a chart in Excel, you have an option of putting the actual number in on the bar as a value, or you can put in the percentage, which makes it much more easier for somebody reading the chart. Okay. So you must remember, like number 3 is not a rule. Okay. But if adding values, that's going to make the person reading your chart a better understanding of what's going on in the chart. All right. Any questions about that one? Okay. Number 5, data are collected, summarized, and analyzed, and a decision is made based on instinct. This is a typical use of statistics. True or false? Okay, so if you want to respond to that. Hey, John, can you respond, please? Or if you don't know, it's a no response. Okay. All right, John. Why is using instinct a typical use of statistics? Can you explain that? You made a mistake. All right, Roshani, you said yes, using instinct is typical use of statistics. Why is that?
I think after collecting, summarizing, and analyzing the data, then
I'm
we
sorry, say
can
that
use,
again. You better speak a little louder.
after collecting, summarizing, and analyzing data, we can
Yeah,
make we can make decision based on instinct. I think.
but do you understand what instinct is?
Yeah, it's a feeling.
Right, but it's not, okay, instinct is based on, yes, Amir, it's your gut feeling, like you think it's correct. The reason you're collecting, summarizing, and analyzing the data is to take that away, to eliminate that. So there's no instinct based on in your decision making. It all is all based on evaluating the data. So the correct answer is false. It is not a typical use of statistic. Instinct works every time. Is that correct, Tony? Why? Tell me how instinct works all the time. Oh, you're joking. Okay. All right. That's good. Okay. Yeah, lighten the humor. All right. Okay. The number of classes, remember, classes in a frequency distribution is typically between 10 and 20. True or false? Hey, Roshani, do you know what the answer is, or you don't know? Okay, that's fine then. All right. So Noah, you said true. So the number of classes on a frequency distribution is typically between 10 and 20. Why is that true? Okay, why is that true, Noah? Can you tell me why? Noah, are you there? Okay, it didn't say 1 to 3, it said between 10 and 20. Oh, you mean have smaller classes. Okay. Okay. All right, everybody. Noah is correct. Is typically between 10 and 20. If you have too few classes, then you're putting too much data into the smaller number of classes. If you have too many classes, and you're not restricted to 10 to 20, but usually it is between 10 and 20 classes. Of course, it depends on how much data you have. Are there any questions about that? No? All right. So just so you know, the number of classes is generally between 5 and 15. I have very rarely seen any number of classes at 15 because you should have an enormous amount of data. So if you want to follow some rule, the smaller the sample size, the smaller the number of classes. The larger the sample size, the greater number of classes. All right? Okay. So the midpoint of the class interval 10, but less than 12, is equal to 10.5. Is this true or false? Okay, John, that's fine. All right. Wellington, you said that's false. And why did you say it's false? It's 11. Okay. Is your name Wellington, Amir?
Uh, it's because when you have like 12 and 10, you have 2 points. So the middle of 10 and 12 is 1. So 10 plus 1 is 11. That's the middle.
Right. Okay. Remember, you have to look at how many points are you talking about, and if it's an odd number, you're going to look at in between. If it's an even number, you're just taking the two numbers and dividing by 2. Okay, which gives you 11 in this case. All right. So it might be said that the stem and leaf display is really a quick and easy way of creating a rudimentary chart or diagram for numerical data. If so, which chart is used to describe categorical data does it most closely resemble? The stem and leaf display most closely resembles a rudimentary Pareto chart. The stem and leaf display most closely resembles a rudimentary bar chart. The stem and leaf display most closely resembles a rudimentary pie chart. And number 4, the stem and leaf display does not resemble any of the above charts or diagrams. Okay, let me just put the poll up. So I urge those people that don't know, look at the notes and look at the text. Okay?
Professor, this is the answer. We cannot choose a question.
Sorry, you cannot choose the question?
Yeah.
Oh. Oh, you mean because it's not underlined?
No, we cannot choose here like on the
Oh,
pool that you are doing.
oh, okay. Let me, I'll do it again. Okay, that's not working. I'll try it again. All right, try it again. Hey, Amir. Amir, John, Roshani, and Song. No, well, you have to check that later, John. Amir, John, Roshani, and Tony. If you're not sure, just indicate. Okay, Amir. Roshani, are you thinking about it? Okay, then keep it as a no response. Amir, no response? Oh, okay. All right. So nobody said a Pareto chart, which is true. Okay. We didn't talk about it very much. I wouldn't worry about it. Just give it a quick glance in the text. One person said resembles a rudimentary bar chart. Noah, why does it resemble a bar chart? Noah, are you there? It would look similar. Okay, thank you. Tony, you said resembles a pie chart, and can you tell me why? Why does a stem and leaf display look like a pie chart? Oh, you don't know? You just guessed? Don't get. Sorry, don't guess. Don't guess. Wellington, you said the same?
No,
Why?
I thought the same as Noah, but like
Oh, you
similar,
thought?
but with the percentage, with a pie chart.
Okay. And Amir, you said it doesn't look like any of the charts. Why is that? It's a specific diagram. Okay. The correct answer is it resembles a bar chart. Okay, Noah was correct. If you turn it on its side, it looks exactly like a bar chart. Okay, you have your x-axis and your y-axis, and the y-axis are the leaves. The stem is the x-axis. Okay, all right. Good one, Noah. All right, so number 9, the width of a class interval in a frequency distribution or bar chart will be approximately equal to the range of the data divided by the, and you tell me what it is. And as soon as I get that. Okay, so please fill in your responses. John and Tony, are you not sure of the answers? Okay, John. Tony, what about you? You forgot. Okay. So you can be in the no response. And everybody else is correct. Okay. So it's the width of each class is equal to the lowest value in the data set. Very good. Excellent. The width of the class interval to be range divided by the number of classes. Remember, you can always look at this. Number 10, when constructing a frequency distribution, which of the following rules must be followed? Adjacent classes cannot overlap. The number of classes must be an even number. The width of each class is equal to the lowest value in the data set. Or number 4, the midpoint of each class must be an integer. Okay. Brenda, are you sure your answer, or you don't know? If you don't know, just keep it at no response. And Roshani, are you sure or not sure? Okay, just keep no response. Brenda, are you sure or not sure? Okay, so no response. All right. So we have a split. Okay, John. All right. So Wellington, you said number 3. The width of each class is equal to the lowest value in the data set. Why is that true?
Because like this represent when you make a bar chart. Bar chart, no, sorry, the frequency distribution. I think is this one. I don't know how to explain this, but I feel like it's
Yeah. Okay. All right. I'm just going to tell you that's not correct. Okay.
So my gut feeling is not.
Yeah, it does not have to equal the lowest value in the data set. Okay. And John, why did you say number 2? The number of classes must be an even number. Why is that? No, you do not have to make the parts of the chart even. Okay. All right. So the one important rule that the other 3 people correctly answered was that adjacent classes cannot overlap, which means you have to have unique numbers within each of your classes. Okay? Are there any questions about that? All right, we'll keep going. That's not the correct answer, so that was from the other question. The movie theater industry tracks ticket sales by age groups. A pie chart would provide an appropriate representation for the proportion of ticket sales attributed to each age group. True or false? Roshani, are you not sure about this question? Just let me know. Okay, so. All right, John, tell me why this is not true. What do you mean by intervals? I'm not sure what you mean. The pie chart would be measuring different age groups and their responses. Okay, why is a pie chart not able to capture different age groups? Okay. Remember, age groups are a category. Everybody else is correct. Okay? So the pie chart is going, remember in a pie chart, it always adds up to 100%. The movie theater industry tracks ticket sales by age groups. It's still going to add up to a number. It's always 100%. So you're just dividing the total sales by the number of age groups that you create. Okay, you know, you can have an age group 0 to 10, whatever, 11 to 20, whatever it is. It's just putting the different ticket sales by the age group, which adds up to 100, which a pie chart is actually measuring, which is probably the most appropriate. So a pie chart would represent the percentage of movie tickets purchased by each age group. All right, question 12. What method is used to sample a population so that it is representative of the population? Okay, hope that makes sense. what method is used to obtain a sample? Or what process, what technique? Every other element in a population is chosen. Samples are chosen at random from the population. All but the observations that have the lowest and highest values are selected. Only the first half of a population is selected. John, are you sure or not sure about this question? Okay, so I'm happy to say everybody is correct. Samples are chosen at random from the population. Excellent. Okay, good job. All right. You are constructing a histogram that is required to use 6 classes for a data set that ranges from 15 to 70. A class width of 9 units would be an appropriate choice. True or false? Okay, Song, that's good. Just keep no response. Amir, Roshani, if you're not sure, tell me. Okay, Roshani. Amir. Okay, John, you're not sure. Okay. So, Amir, correct. I don't know if everybody sees that. Okay. Which is when you round it, what does it become, Amir? 9.4 rounded becomes 9. Remember, you're rounding down. Noah. Okay. But you're correct. Okay. Wellington and Brenda, do you see that? Let me show you.
No, yes, but I thought it would be like rounded, you know. So because of
Yeah.
the points, normally we don't round, but now I understand.
Okay. So, I mean, if you look at this slide, using the class width to be the range divided by the number of classes, 70 minus 15 divided by 6 equals 9.167. If a width of 9 is used, the largest data point will fall beyond the 6 class interval. Therefore, a width of 10 is a more appropriate choice. Okay. All right. The professor of a business communication course wishes to provide feedback to students regarding their performance on the last exam. A histogram would provide more information than a stem and leaf display. Is that true or false? Oh, sorry. Okay, true or false? Okay, not sure, don't respond. It's plenty of information, Amir, plenty. It's like if you got back the test, that's your grade. Okay, so John, Noah, Rashani, and Wellington, you're not sure? Just indicate you're not sure. Otherwise, can you please vote? Oh, sorry, I apologize. Okay, all right. So, Brenda, why does that be true? The answer, a histogram would provide more information than a stem and leaf. You can just Brenda, if you just want to use the chat, why did you say, oh, more information?
Professor, sorry, I misunderstood the question because I thought histogram would like
Well, it
display.
says a histogram would
My answer
provide
is
more
false.
information. Is that true or false?
It falls.
It's false.
Yeah.
Okay. All right. So okay. So it's false because it's not providing any more information. It's providing the same information, but in a different visual method. Okay, for those people that didn't know, remember what a stem and leaf is. So we talked about it earlier. If you flip it on its side, the stem becomes the x-axis and the leaves become the y-axis. Okay, so it's basically a bar chart. It's a histogram. Okay. Are there any questions about that one? Okay. All right. So in this question, we have frequency distributions. I hope you could see it. So the rule of thumb for creating a frequency distribution is to divide the data into 5 to 15 classes. While larger numbers of classes allow for larger data sets, how do you know exactly how many classes to use? If in doubt among the number of classes, select 10 since it is the midpoint between 5 and 15. Determine the width of the class interval, then calculate the number of classes. Select the number of classes that provides definition to the shape of the data. Any number of classes between 5 and 15 is sufficient. Okay, let me just remember, if you don't know, keep it at no response. Okay, thank you, John. All right, Wellington. Okay, Noah. So is Amir the only one? I guess so. Okay, Amir, why did you select number 2?
Because as I remember, we mentioned that in class before, but I forgot the exact code that we use. So
Okay, so you determine the width of the class interval, then calculate the number of classes.
yes, sir.
Okay, good job. Okay, everybody? All right. Next question. The following numbers represent exam scores in an accounting class: 78, 93, 85, 81, 73, 96, 72, 86, 90, and 85. If a stem and leaf diagram is developed from this data, how many stems will be used? Whoop. Let me just get that. Okay, that's fine, Roshani. It better you don't know instead of guessing. You can't see your response, John? It says number 1. Roshani and Tony, are you sure or not sure? Roshani, sure or not sure? Can you hear me, Roshani? You said already. Oh, I'm sorry. I am sorry. I forgot. I apologize. Okay. Tony, why did you choose number 2? There's 10 marks. Oh, it's the total number. And Wellington, why did you choose number 2? Same. Okay. Can someone, all right. The marks are in the 70s, 80s, and 90s. So there's 3 stems. And the leaves are like, yes, Brenda, correct. It's 7, 8, and 9, right? Okay. Those are your stems. I would suggest to go back and look at the stem and leaf, what the definition is, as Brenda said, the roots. Okay, so the correct answer is 3. All right, I don't know whether you can see the figure here. It looks like hourglasses. So let me read it. In the above figure of wine imports into the United States, what 3 guidelines for developing good graphs have not been followed? Unnecessary adornment, adornment just means like extra little things that really have nothing to do with the graph or the information. Vertical scale does not begin at 0, no title. Distorted data, unnecessary adornments, vertical axis not properly labeled. 3, distorted data, x-axis not labeled, no title. Distorted data, unnecessary adornment, no scales for either axis. Okay, so if you can respond. Okay, John. So the people that have not voted, you're not sure? Yours was a misclick. So I don't think anybody is responding or anybody understands this one. Okay. So what I'm going to tell you is there a title here? Yes. Okay. Yep. And is there a vertical scale? Not really. Okay. So the vertical axis is not properly labeled. Okay. We've got it here. So the correct answer for this one is number 3. The data is distorted. It really doesn't tell you anything. The x-axis is not labeled. Oh, sorry, not number 3. I'm sorry. It's number 2, distorted data, unnecessary adornment, and vertical axis is not properly labeled. Okay? All right. We'll do one more and then stop. Okay. So, considering the various types of tables and charts introduced in this chapter, which table, chart, diagram, or plot would you use to depict categorical data for 2 variables in a visual format? A side-by-side bar chart, a contingency table, which we touched on very briefly, a scatter plot, or a pie chart? Amir, are you still thinking? Brenda, okay, thank you. Tony? You're still thinking? Okay. Tony, are you sure or not sure? You're not sure. Okay. All right. So Brenda, can you tell me why you chose side-by-side bar chart?
Hello?
Hello, yep.
Yeah, sorry, I refreshed my web. So I chose number 1 because there's only 2 variables, and then it's easier to show the result for those 2, I think.
Okay, and is a side-by-side bar chart good for that?
I think so.
Why?
I don't know, I'm not sure.
Just, you're not sure. Okay.
No, I'm
Okay.
not sure.
You're not sure. Anybody else who chose number 1? Okay. Amir, why
If I
did you
ca-
choose number 1?
if I just add to what Brenda said, so there is 2 options for this question is pie chart or bar chart, right? So
Sorry, what did you say?
I said there is 2 possible answer for this question is pie
No,
chart
there's
or
not. There's only one no, there's only one answer for this question.
but we are looking for the better answer, right? So I think for this question is bar chart because you can see it's more readable because we compare heights, and I I remember that we mentioned pie chart for more than 2 variables. That would more helpful.
Okay, and Brenda, you're saying comparison of 2 results can be shown better with a bar chart. Okay, Noah, why did you say pie chart? Noah? can just type in your answer if you want, or use the microphone. Noah, you have a reason for your answer? Okay. So how do you do two categories in a pie chart? No. To eat it, yes. To display it, no. The pie chart, a pie chart only has one category and many classes within the pie chart. Okay. And Wellington, you said a scatter plot.
Yeah.
Okay.
But
Okay. Why is scatter plot?
I think scatter plot you can like organize and see like how much there is in one and in another, so it's different. So I think you can see better.
Oh, so you're saying it's easier visually to see what the pattern looks like. Is that
Yeah,
right?
yeah.
Okay. Okay. It's not readable for most people. Okay, well, I guess Amir, you got to put your glasses on. No. It, you're assuming the data doesn't cluster together. You're assuming the points are all over the place. In fact, the correct answer is Wellington number 3, the scatter plot, because all you have is x, y, and it's easy just to point, for this value of x, you have this value of y. For this value of x, you have this value. The scatter plot is easiest because it says, oh, well, maybe the points are clustered around some area, or they're not clustered, or they're scattered too much. It will show you immediately because you're looking at the relationship between x and y. Is there a relationship? If there's no relationship in a scatter plot for x and y, the points will be all over the place. If there's a relationship between x and y, the points will cluster around a certain area on the graph. Okay, so how in a bar chart are you going to show the x and y? Because what are they measuring? They're two different variables. So how do you tell the difference between them? How do you explain that? You're measuring eye color with height of a person. Ah, you got it. Okay, does everybody have that? Everybody understand that? Okay. These are two independent variables. A bar chart is not going to show you anything. Okay. The scatter plot is going to show you, because what you're doing is you're looking at the relationship. No, you can't combine them. They're two independent variables. You cannot combine them. And so a scatter plot is showing you the relationship between the two. Okay? Does everybody understand that? That's why you have a scatter plot, because it's looking at if a relationship exists or a relationship does not exist between two variables. Okay? All right, we're going to stop there. And what I urge you to do is look at these files. I notice there's some errors, so please tell me what errors there are. It may have been repeated some answers from previous questions, but look at this. We're going to continue with chapter 2, and for sure we'll probably finish chapter 2, and then we'll start chapter 3. And hopefully you're working on your case study. And, we finish all the chapters, so there's no homework. And have a good weekend. And I'm still available Monday and Wednesday if you have any questions. So whether it's about your case study, whether it's about the content. All right, so everybody take care. And if I don't see anybody or talk to anybody on Monday, we'll see you on Tuesday. Okay?